Beyond RAG, context management loop. Here's why that difference matters in production. Retrieving more relevant-looking passages can improve recall and still reduce answer quality. Hard negatives, duplicated evidence, and plausible distractors can overwhelm useful material. The failure is not always the retriever, and it is not always the model. Acquisition is only one part of deciding what the model should know now. I'm Mehrdad. In this video, I'll show you the complete control loop. Require, acquire, admit, assemble, verify, and retain. A model call contains more than evidence. It carries trusted instructions and authorization constraints. It carries the current objective, prior decisions, commitments, and open questions. It may carry retrieved passages, user files, tool results, tool definitions, and provider-specific continuation state. And it needs generation reserved for reasoning, calls, structured output, and the answer. Context management allocates and maintains this complete working set. RAG changes how external evidence can enter one layer. It does not, by itself, decide which policy remains active, which workflow state survives, or how much room the model needs to finish. Start by defining what the next call requires. Only then choose how to acquire missing evidence. Sometimes the right route is no retrieval because the user already supplied a complete packet. Sometimes it is direct loading of a bounded, authorized source set. Sometimes focused RAG is the efficient route into a large or changing corpus. And sometimes the system must search iteratively because one finding changes the next question. Every route still passes through admission, assembly, verification, and retention. If this is useful, like the video and subscribe for the rest of the context management series. Consider a procurement assistant preparing a supplier renewal recommendation. The source packet includes a master services agreement, a pricing amendment, a security assessment, the current approval policy, a newer exception memo, and historical email. Before searching, define the context contract. The goal is a renewal recommendation, not a document summary. The trusted policy says which approvals are mandatory. The task state records what reviewers already decided and which questions remain open. The evidence questions cover price, termination, security, and exceptions. Every consequential claim needs a source identifier, version, and effective date. The answer also needs enough reserve for a recommendation, unresolved risks, and citations. That manifest tells the system what sufficient context must contain. Choose the route from the task shape, not from an architecture preference. Use no retrieval for bounded transformation or reasoning when the evidence is already present. Load the full authorized packet when cross-section structure and holistic comparison matter, but test whether the model can use that length reliably. Use focused RAG when the corpus is large, frequently updated or dominated by local questions. Use iterative or hybrid acquisition when the assistant must follow dependencies, such as finding a discount clause and then checking whether a newer exception changes it. There is no universal winner between retrieval and long context. Full loading removes retriever omission, but moves evidence selection into imperfect model attention. Prompt caching may lower repeated prefix cost or latency. It does not make stale evidence current, expand capacity, or prove the packet is sufficient. RAG is a complete retrieval-augmented generation architecture, not merely a vector database and not merely a retriever. In a common production path, the system forms a query, searches semantic and lexical indexes, merges candidates, re-ranks them, expands selected chunks to recover surrounding meaning, and supplies evidence to generation. Query rewriting can improve a poor initial match. Hybrid retrieval can recover both conceptual similarity and exact identifiers. Contextual retrieval can preserve document-level meaning that isolated chunks lose. But none of these mechanisms proves that a candidate is authorized, current, authoritative, or sufficient for this decision. In our supplier packet, a real discount clause may rank first while a termination clause elsewhere and a newer security exception remain missing. RAG acquires and uses external evidence. The context manager still owns admission, assembly, verification, and what survives afterward. Focused retrieval and full loading remove different failure modes. Retrieving only the highest-ranked passages can miss a bridge document, fragment a qualification from its clause, or return hard negatives that look almost correct. Increasing how many candidates you keep may raise recall while reducing the quality of what reaches the model. Full loading avoids that particular omission, but it does not remove selection. It delegates selection to attention across a larger set containing distractors, obsolete versions, and cross-document dependencies. Position can matter, but there is no universal ordering rule that fixes every model and task. Both routes can produce the same outcome, an insufficient working set that still looks impressive. The supplier assistant may quote the right discount and still make the wrong renewal decision. The control question is not whether retrieval ran. It is whether the active context covers every evidence question. Acquisition produces candidates. Admission decides which candidates may enter. First enforce tenant and document authorization outside the model. Then check source identity, version, effective date, provenance, and supersession. Reject the obsolete approval policy even if its wording matches the question better. Mark the newer exception memo as a potential override instead of flattening it into another chunk. Assembly then compiles the admitted material under a fixed evidence budget. Preserve independently necessary spans. Expand a clause enough to keep its qualifications and document structure. Deduplicate repeated language, surface contradictions, and label every span with a stable citation identifier. Allocate that packet beside trusted instruction, task state, capability state, and generation reserve. Current search platforms can enforce document and field access, and indexers can refresh changed sources, but those controls must be configured and monitored. Relevance ranking should never be asked to infer authority. New research is making context sufficiency explicit. Recent methods evaluate whether an assembled context covers the information needed for long-form generation, not merely whether individual passages look relevant. Others ask whether current evidence is sufficient and omit structured gaps when it is not. Some use a reasoning plan to target missing bridge evidence and correct retrieval during the task. These are recent methods on selected benchmarks, not universal production recipes. The broader design shift is what matters. When the supplier packet contains price and security evidence but lacks the controlling termination language, the controller should not retrieve another generic top-ranked batch. It should name the missing information, reformulate the search, and decide whether to continue, abstain, or escalate. A fixed budget does not require treating every source the same way. Keep exact language when a number, entity, obligation, exception, or citation must survive verbatim. Compress broader background only when its likely losses are understood and tested. Recent work demonstrates this pattern by combining selected natural language passages with compressed representations under a bounded token budget. That is promising recent evidence, not permission to compress blindly. In procurement, preserve the termination clause, current exception, pricing formula, and approval condition exactly. A long history of routine email may be summarized, with links back to the originals. Compression can widen coverage, but it can also erase a qualifier or weaken provenance. Cache the stable packet when the economics justify it, but refresh stale sources and rebuild the packet when policy, authorization, or evidence changes. Do not score the final pros and call the context manager tested. Start at requirements. Did the manifest include the correct policy, task state, evidence questions, and output reserve? At acquisition, measure required document and required span recall, query rewrite success, routing accuracy, and invalid extras. At admission, test tenant isolation, freshness, version correctness, and contradiction handling. At assembly, measure evidence question coverage, duplicate rate, position sensitivity, compression loss, and citation identifier integrity. Then evaluate generation for correctness, faithfulness, abstention, and citation support. A named source is not enough. Test whether it supports the claim and whether every consequential claim is covered. Finally, test retention. Did the decision, unresolved gap, and evidence references survive without carrying accidental transcript bulk? Track cost and tail latency by route, but optimize cost per successful grounded decision, not cost per request. Here is the production checklist. First, define what the next call must know, preserve, and produce. Second, choose the least complex acquisition route that can supply sufficient evidence. Third, admit only authorized, current, traceable, and necessary material. Fourth, assemble for coverage under a fixed budget, preserving exact facts and source structure where loss matters. Fifth, verify missing information, claim support, citation correctness, and whether the system should retrieve again or abstain. Sixth, retain durable decisions, unresolved gaps, and evidence references while refreshing stale material. RAG can acquire and use external evidence. Context management decides how that evidence coexists with policy, task state, capabilities, protocol state, and generation reserve. It decides what the model should know now, what it may trust, and what must survive. If this video was useful, subscribe to Multi-Agent Academy and connect with me on LinkedIn. I'll keep publishing evidence-backed work on agentic systems. We have decided what enters the loop. In video 5, we'll ask what should survive it. I'll see you in the next one.